Hi guys and Assalamualaikum. We are from Group J. We will do a little bit presentation regarding about the investigation on Sif Mons. Without further ado, let's get to know our fellow space explorers. Starting off with me, Muhammad Niqmatullah bin Nazmi, and
Hi, my name is Syaza.
Assalamualaikum, I'm Awangku.
Hello, my name is Shah.
Hi, I'm Hayani.
Hello, I'm Tasyriq.
Hi, my name is Afiq.
As we all know, we have many planets in the universe. Today, we're going to talk about a planet that is also called as the Hell Planet. Want to know why? Keep on listening to understand. Venus is the second planet from the Sun. It is known for its exceptional brightness as it is the brightest object in the sky after the Sun and the Moon, and sometimes looks like a bright star in the morning or evening sky. Venus is also Earth's closest neighbor in the solar system. Made up of iron core, hot mantle, and rocky crust, the structure of Venus is almost similar as the planet that we are living in, the Earth. However, behind this beautiful appearance of Venus, it is actually a world filled with storms and infernos. The difference between Earth and Venus is that the crust of Venus is filled with up to millions of volcanoes. In fact, it has more volcanoes than any other planet in our solar system, with more than 1,600 major volcanoes and more than 1 million smaller volcanoes. This includes Maxwell Montes, the volcano that is almost as tall as Mount Everest. Just by this fact itself, we can guess that volcanic eruptions are a major force of reshaping the landscape. Of course, when we talk about volcanoes, we will definitely think about rangy lava flows, right? So this is one of the reasons why we call the planet as the Hell Planet.
hello again, Nick here. So before we continue our investigation, let us know the main types of volcano. So there are four main types. First of all, it is cinder cone volcano, and then we have the composite volcano, the shield volcano, and lastly the lava dome. So let's go. So out of four type of volcano, which is the cinder cone, composite, and shield, and also lava dome. So which one do you guys think Sif Mons categorized in? Any guess? So Sif Mons categorized in as a shield volcano. So shield volcano is actually a type of volcano named for as a low profile, and it has a resemblance of a water shield which is lying on the ground. So it is formed by eruption of highly fluid lava, which then travels farther and forms a thinner flows than the most viscous lava erupted from a stratovolcano. So down here is actually a representative diagram which shows the type of the shield volcano. Thank you. So now let's get into the best part. So the question in mind is, what is Sif Mons? So Sif Mons is as we stated just now, is a shield volcano in Isla Reggio on Venus. It has a diameter of 300 kilometers and a height of 2 kilometers up to 3 kilometers. It is named after the Norse goddess of Sif. Now you can see the topographic profile of Sif Mons. So as you can see for the right side, you have the north-south profile, which is in kilometers. So the high peaks we can see from the data is actually 2.5 kilometers peak. So the best part is it is consistently, because as you can see in the west-east parts, the profile peaks at 2.5 kilometers also. So this is quite interesting facts for you guys. So we will pass this floor to another friend of mine named Afiq. So he will explain a little bit about the history of Venus exploration. Thank you.
Now, let's move on to Venus exploration history, starting with NASA's own Mariner 2, which is a project by NASA in 1962. And they have been orbiting Venus and collecting pressure and temperature data for Venus. And the second one that I'm going to highlight here is USSR on Venera 4. Venera 4 successfully entered Venus' atmosphere, but due to high temperature and pressure, it cannot come back to Earth. and the similar one with Venera 13. But the Venera 13 successfully landed onto Venus and remained on the surface about 2 hours collecting valuable data for the scientists of the USSR. And the latest one, the NASA Magellan, since the NASA know that the temperature and pressure of the Venus is a challenge for NASA's Venus exploration, they opted to be a satellite for the Venus by orbiting the Venus at a certain altitude, so that the satellite won't be subjected to high temperature and pressure. And until today, the Magellan still collecting data for the Venus. Sif Mons are isolated axisymmetric peak of about 1.7 kilometers, and it is a caldera type volcano of about 40 kilometers in diameter. Sif Mons are relatively rather bright compared to nearby Gula Mons, and it is relatively rather bright compared to the region they are sitting on, which is the Western Isla region. And by radar bright, I means they reflect the radar signature from the space probe itself. This is the image captured from the NASA Magellan space probe.
Moving on to the discussion of our investigation, which will be divided into two parts: volcanic activity, where we discuss on eruption style, morphology, and volcano type, and Venus quakes, where we will be discussing on intraplate quakes and intraplate volcano.
Sif Mons has a relatively slow magma ascent rate, and together with the inside heat of the Venus itself contributed to the dome shape of the Sif Mons. And the lava flow across the reef is relatively slow, and the uniform distribution of the lava flow itself indicates effusive eruption of the Sif Mons.
Moving on, as mentioned in the previous slides, Sif Mons is a type of shield volcano which resulted from large hot plumes from Venus's hot mantle core body. It is axis-symmetrical and appears to be domical in shape. This dome shape extends with a radial flow of approximately 500 kilometers in diameter. As a shield volcano, Sif Mons will also have its own caldera collapse and pit chains. In the map on the right, we can see a radar duct flow represented by crosshatch markings. This could be either AA lava flow or Pahoho lava flow, or both. And at the top right, we can see the dome-shaped depressions, which are the calderas of Sif Mons. Starting with the biggest one on the summit, which is 40 kilometers in length, the central caldera, followed by two smaller nested caldera, each around 10 kilometers in length. There are also lots of pit chains, comprises of depressions of less than 1.5 kilometers.
Venus quake. A quake is the result when the surface of a planet, moon, or stars begin to shake, usually as the consequence of a sudden release of energy transmitted as seismic wave and potentially with great violence. The intraplate quakes, these intraplate Venus quakes are caused by stresses within a plate. Since plate move over a spherical surface, zones of weakness are created. So intraplate quakes happen along this zone. Intraplate volcano. It is referred to hotspot or interplate volcanism. Heat from the mantle plume causes melting and thinning of the crust, which leads to volcanic activity at the surface. Despite similarities in size and composition, Venus and Earth evolved along different tectonic pathways. Earth developed a full system of moving plates, whereas Venus represents a one-plate planet. As a consequence, the regional and local effects of tectonic and magmatic activity on Venus might be best defined as intraplate. Although Venus lacks plate tectonic, the main source of seismic energy on Earth, significant seismic activity can arise when there is distributed lithosphere deformation, just as it does with intraplate tectonic on Earth.
In conclusion, we should continue to explore our solar systems and the universe to find out more interesting volcanoes which would further to enrich our knowledge. Based on what had been presented just now, here are some important points of our presentations. Firstly, Venus has more volcanoes than other planets, and the eruptions had been the major force that changed the landscape. Secondly, Sif Mons, which is a shield volcano, it produced low viscosity runny lava that spread from the source, from below. And thirdly, based on our 4 series of exploration done on Venus, we should note that exploration on Venus are mainly related to distance, temperature, atmospheric pressure, and clouds. Next, to know about the Venus volcanic activity, we should then note about its eruption styles and morphology. For the Sif Mons eruption style, we should know that the volcano is a dome-shaped volcano due to the inside heat of the core. Secondly, it has slow magma ascent rate as well as slow lava flows. Because of these properties, it should be said that Sif Mons erupt effusively and not explosively. We could also see that Sif Mons are actually formed by layers of lava until it becomes a dome shape because of the uniform distribution of lava outside the volcano.
For morphology, it should be noted that there are 40-kilometer collapse at central caldera, which is a main appearance of Sif Mons. In addition, there are also 2 smaller nested caldera, each in 10 kilometers of diameter. Thirdly, pit chains comprised of depression of less than 1.5 km in diameter also appeared on Sif Mons, and based on the observation, Sif Mons consists of 2 types of lava flow, which is Paoyoe, which is solidified and smooth, as well as Aa lava flow, which is rough and jagged. Summary of the geologic history of Venus compared with Earth. On Earth, the plate tectonic system contains complementary amounts of compression and tension throughout this period. On Venus, tectonics are dominated by phases that oscillates between predominantly global tension and compression. On Earth, during this period, the rate of volcanism appears to have been relatively constant. The majority of volcanism is at mid-ocean ridges and the minority is at intraplate sites. On Venus, rates of volcanism peak early in this period, and the dominant style changed with time. That's all from us. Thank you for your attention.
So, do you guys have any questions?